Hey guys, today we're going to do Chapter 9, Section 4, which is on polynomial division and the remainder theorem. So dividing polynomials is a really big part of advanced algebra and pre-calculus basically. So it's really important to know how to divide polynomials. Before we start dividing polynomials, I think it would probably be a good idea if we just reviewed a quick dividing of normal numbers. Okay, so let's just talk about long division in the first place, and I'm just going to make up a problem here and then I'll erase it because I didn't put one on the notes, but I want to make sure that we know what we're doing. So let's just say I want to divide 1039 by 5. Okay? So when you're doing long division, you always start with this first number here. So I say, can 5 go into 1? And the answer is no. So then I say, well, how about, can 5 go into 10? Yes, it can go into 10. So it goes into 10 two times. So I write a 2 up top, and then I multiply these two numbers together and write that number down here. Then I subtract those numbers, and I'm left with 0. So then I say, well, can 5 go into 0? And the answer is no, I need more numbers, so I'm going to bring down a 3. And then I say, can 5 go into 3? And again, that answer is no. So I need another number, I'm going to bring down that 9. So now I say, can 5 go into 39? And the answer is yes. So I think about how many times can 5 go into 39? And I know that it can go into 39 7 times. So I write my placeholder here, and then I write my 7. So then I say 5 times 7, that gives me 35. When I subtract those numbers, I get 4. So the answer to this problem is that when you divide 1039 by 5, you get 207 with a remainder of 4. Another way you could write that is 207 plus 4 over 5, or 207 4/5. Okay, so now that we've reviewed a normal long division problem, polynomial division is the same exact process. It's just now we're talking about polynomials instead of just normal numbers. So I'm going to go ahead and erase this. Okay, our first problem is we want to divide this polynomial by x plus 5. So I'm going to start by writing x plus 5 on the outside, and I'm going to divide negative 2x cubed minus 7x squared plus 10x minus 25. Okay, so the first thing I do is I say, can x go into negative 2x cubed? And the answer is yes. So I say, how many times does x go into negative 2x cubed? In other words, what I'm thinking about is, what do I need to multiply x by in order to get negative 2x cubed? So I need to multiply x by negative 2x squared in order to get negative 2x cubed. So now I'm going to go ahead and multiply these through. I'm going to say x times negative 2x squared. That gives me negative 2x cubed. Then I say 5 times negative 2x squared, and that gives me negative 10x squared. So now I can go ahead and do my subtraction. When I subtract these two things, they cancel out. When I take negative 7x squared minus negative 10x squared, that's the same thing as negative 7x squared plus 10x squared. So that's going to leave me with 3x squared. So now I say, what do I need to multiply x by in order to get 3x squared? And then answer is 3x, so that's what I'm going to put up here. So now I can go through and I can multiply these through. I can say x times 3x squared gives me 3x squared. 5 times 3x squared gives me 15x. Sorry, not 3x squared, just 3x. And I can pull this 10 down. So now I can subtract, and this cancels out, and 10x minus 15x gives me negative 5x. Okay, and I can pull this number down. So now I say x times negative 5x. What do I need to multiply this x by in order to get negative 5x? Well, the answer is negative 5. So then I multiply it through. I have x times negative 5. That gives me negative 5x. I have 5 times negative 5. That gives me negative 25. And that leaves me with a remainder of 0. So when I divide this polynomial, negative 2x cubed minus 7x squared plus 10x minus 25, by x plus 5, I get negative 2x squared plus 3x minus 5. Essentially what I've just done is factored this polynomial into x plus 5 times negative 2x squared plus 3x minus 5. So if I were to multiply these two polynomials together, I would get this original polynomial here. So essentially you can use this as a tool to help you factor, because then now you have a quadratic that you can factor, and you've got your binomial here that you've pulled out. Alright, let's do another one. So this one's just a little bit trickier because now we have to talk about the concept of placeholders. So here I have 2x to the fourth minus 8x cubed plus 12, and I'm dividing it by x squared minus 2. So notice that I'm missing an x squared term and an x term from this polynomial, and I'm missing an x term from this polynomial. Whenever that's happening, you always have to put a placeholder in to make sure that you're able to multiply and divide and add and subtract in the right order. So I'm going to write this out. I'm going to write x squared minus 0x minus 2, or plus 0x. It really doesn't matter. And then over here, I've got 2x to the fourth minus 8x cubed plus 0x squared plus 0x minus 2. Oops, sorry, plus 12. Okay, so now that I've got my placeholders in, I can start the process of long division. So I'm going to say, what do I have to multiply x squared by to get 2x to the fourth? And the answer is 2x squared. So then I take x squared times 2x squared, and I get 2x to the fourth. I take 0x times 2x squared, and that gives me 0x cubed. And then negative 2 times 2x squared gives me negative 4x squared. Notice that now that I have my placeholders here, my x cubes, my x squareds, and my x to the fourth match up. If you don't have a placeholder there, you're going to end up with stuff like x cubed minus x, and that doesn't make sense because we can't actually subtract that. So now I go through and I do my subtraction. So this cancels out. Negative 8x cubed minus 0, that's just negative 8x cubed. 0 minus negative 4x, well, if I'm subtracting a negative, that's the same thing as adding, so this is plus 4x squared. And then I can bring this placeholder down here to have a 0x. Now I go through again, I say, what do I need to multiply x squared by in order to get negative 8x cubed? So I need to multiply this by negative 8x. Now I go through and multiply, so this gives me negative 8x cubed. 0 times negative 8x gives me 0x squared. Okay, negative 2 times negative 8x gives me plus 16x. Now I can go through and do my subtraction again. So when I subtract these, I cancel. 4x squared minus 0, that gives me 4x squared. 0 minus 16x, that gives me negative 16x. And I can bring this 12 down here as a placeholder for my last term. And now I go through and I say, what do I need to multiply x squared by to get 4x squared? And the answer is 4. So now I go through and do my multiplication. So I get 4x squared plus 0x minus 8. Okay, so now I can go through and do that subtraction. These guys cancel. Negative 16x minus 0 is just negative 16x. And 12 minus negative 8, that's 12 plus 8, so that gives me plus 20. So you'll notice that now I can't go any further because this is an x squared term and this is an x term. So I can't take this times anything to get that unless I'm doing fractions, and I'm not going to worry about that. So now I need to write my final answer. So my final answer is going to be 2x squared minus 8x plus 4. And you could either write with a remainder of negative 16x plus 20, or you could write plus negative 16x plus 20 over this function here, x squared minus 2. So it's just like I did before with that number problem where I put my answer as 4/5 because I was dividing by 5. So here I'm putting my answer as my remainder divided by the thing I'm dividing by. Okay, so this is like my fraction term of my polynomial. So again, this is important because essentially I just factored this polynomial. Now this one comes out with a remainder, so this would not be a proper factored form. You can't have a remainder when you are actually factoring. Alright, last one. So now I want to divide 6x cubed plus 3x squared plus 14 by x plus 4. So I've got x plus 4 on the outside, and then I've got 6x cubed plus 3x squared plus 0x plus 14. Remember, you've got to have that placeholder in there. If you forget that, you're going to run into trouble. So if I do x times 6x cubed, or I need to think about what do I multiply this by to get this, it's going to be 6x squared. And then if I multiply this through, I've got 6x cubed plus 24x squared. When I subtract 3x squared minus 24x squared gives me negative 21x squared. I can bring this guy down. I need to say what do I multiply this by to get this, and the answer is negative 21x. So now when I multiply that through, I've got negative 21x squared minus 84x. When I subtract that, I get 84x. And then I can bring this 14 down. And then I know that I have to multiply this by 84. So when I multiply that back through, I get 84x plus 336. And that gives me a remainder of negative 322. So my answer is going to be 6x squared minus 21x plus 84 plus negative 322 over x plus 4. Okay. And that is all of our polynomial divisions. Now we just need to talk about the remainder theorem. So the remainder theorem says that if we can divide by x minus c, then the remainder of that polynomial is going to be f of c. So in other words, if I can divide, like this one, I can divide by x plus 4, which is the same thing as x minus negative 4, then if I plug a negative 4 into my original function, that would give me the remainder, which should be negative 322 in this case. So go ahead and try that on your own, and you should see that it works. And I'm going to let you guys check your own remainders for 1 and 3 using the remainder theorem. And that is everything for section 4.